repeater. So here's our code flow chart for our microcontroller's final project. We started out with some register setup. First off, we set port D as a digital input. We used only pin 4 to deal with the ultrasonic radar, so the rest of them are output and just that one is the input. And then we had our OSCON set up like we normally do for labs, just to set up the right frequency for the clock for the PIC-18. And then we also used timer 0. We just set that to 88, which is enable it with no prescaler. And then last but not least, we also had CCP4Con, which is just the PWM for the speaker that we used. So that's all the register setup. After that, everything went in a while one loop so it could repeat. And what we did inside that loop is we basically just set the trigger pin to high for 10 microseconds. We had to calculate the 10 microsecond delay for our PIC-18. We set the trigger to high, and then we set it to low after those 10 microseconds. And once we set it to low, we start our timer 0, and then we wait until we hear an echo back from our radar. Once we receive that echo, we stop the timer and read the value in. And then from there, we had to calculate some distances. It ended up being a divide by about 58, and then we added one just to help scale it to be more accurate with how far it actually was away from us. And then from there, we just passed that distance into our beep function, which basically just set our speaker to high, delayed for the amount of distance that we were at, and then set it back low. And then we came all the way back up here to the wild one.
Okay, so here is the hardware of our project. Obviously, we have the PIC-18, and the most notable part is our ultrasonic sensor. We have 4 pins on there. We have the power, the ground, the trigger, and the echo, which all come on down to here, which this orange wire is our trigger, the green wire is our echo. And so basically what we do in the software is we send a 10 microsecond pulse to the trigger, which makes the ultrasonic sensor send out a pulse, and then we wait for the echo, and once we receive the echo back on in this port, then we take that and we do our calculations with the amount of time that it took for that to come back. Other than that, we have our sound output pin for our speaker, which goes through a resistor, and it goes at a constant frequency, so we didn't mess with that. This is our speaker, just plugged into that resistor and to the power. And other than that, we have our battery pack, which powers the whole thing at about it's three 1.5 volt AA batteries, so about 4.5 volts, but it's pretty lenient on the voltage that we use for it.